Welcome to EDU World Space.
Hello there. Okay, so for this exercise, we have a case of two persons that are going to pull horizontally on ropes attached to a post, and they are going to form an angle of 60 degrees. So this value here is really important. So basically, we're going to have a person A that's going to pull with forces of 150 pounds, while the person B is going to pull with a force of 110 pounds. So the first thing that we need to do in this part is to draw a figure to scale that graphically represents these three forces. And the resultant force is the sum of the two vector forces. Okay, so basically that consists to choose an appropriate coordinate system. Okay, so basically the pose is going to be at the origin. So here we have the xy axis. So we're going to assume that here in the middle it's going to be the post. So the easiest choice for the forces are going to be a force that is going to be aligned with one of the axes. In this case, it's going to be aligned with the x-axis for simplicity. And the other one is going to form a 60 degrees angle with respect to this force. So that's going to be the second force. It's going to be this one here. Okay, so this vector here corresponds to the force performed by the person A. That means that the force from A is equal to 150 pounds, and the force performed by the person B, it's going to be equals to 110 pounds. And what is important is that the angle that they form is theta, and this is equals to 60 degrees. Okay, so that completes the first part that corresponds to the diagram of these forces. Now you need to draw also the resultant force, like the sum of these two forces, and that means that we need to take here, we know how to sum graphically. So first we move to A, and then we're going to move to B. Okay, so that's going to be that vector. So let me draw it here from A, and then we add, yes, so from B, this, so from first we advance to A, and then we advance to B, and this is going to be the resultant force, this one. Okay, so let me do it better. So the way to draw is the sum of these forces. So first we go to A, then we sum B, and the resultant force is going to be from the origin to this point. Okay, and this vector that you find here, the result, is the sum of the force from the person A plus the force of the person B. Okay, so these are these three forces drawn on this diagram. Okay, that's the first part of this exercise. Now for the second part, we need to use, of course, trigonometry to determine the formulas for the vectors, and then we need to perform algebraically the addition of these forces and obtain the angle of the resultant force that makes with A. That means that this angle here, going to call it phi. Okay, so we need to find first this vector and then this angle phi here. So we need to do this algebraically. The first thing that we need to do, I'm going to eliminate this for a while. We need to know what's going to be the angle. We need to know the components of the force B. The force A, it's trivial. If this is the x-axis, this is the y-axis in this coordinate system, then the force A will be just 150 pounds in the I direction. But in order to have what's going to be B, we need to use trigonometry, and that's the part that they say, and we need to use the angle. So basically we know that the x component, it's going to be this force times the cosine of the angle, right? And for the z component, we need to take fb times sine of the angle. Okay, so don't forget that this is the vector, not the magnitude. So the ith component for this vector is going to be 110 pounds times the cosine of the angle that they form, and we know that this angle is equals to 60 degrees, so the angle is the cosine of 60 degrees in the ith component plus 110 sine of 60 degrees j. And from here we obtain that the vector of the person B, it's going to be 55 ith plus 55 square root of 3j. Great, so now we have the components for each vector, and we can compute the sum of these two vectors. So the sum of these two vectors, fa plus fb, is going to be equals to 205 I plus 55 square root of 3j. And then we need to obtain the angle that form this new vector, this resultant vector, with the person A. So that's the angle phi, and to do that we know that there is a formula for that. So let's call this the resultant force. F sub r is equals to 205 in the ith component plus 55 square root of 3j, and the vector fa was equals to 150 in the direction. Now let's remember here that the angle between two vectors is equals to the r cosine of the dot product. So let's say the vector u and the vector b. We want to know the angle between these two vectors. Well, we need to take the dot product of them and then divide them by the norms of each vector, and this is the formula to find the angle. Okay, so we need to compute what's going to be the dot product between these two vectors. Here forgot the arrow. And the dot product of these two vectors is equals to 30,750. And then the corresponding norms. So the norm for the force R is equals to 10 times the square root of 511. And the norm of the vector of the force A is equals to 150, because we only have components in the I direction. Okay, so with all this data here, we can compute the angle using this formula. So basically the angle theta f5 in this case is equals to the arc cosine of 30,750 divided by 1,500 times the square root of 511, and this corresponds to an angle of 24.92 degrees.